I mentioned briefly in the last lecture that we can have functions that don't have a name, and these are called anonymous functions or lambda expressions. And so most functions have an identifier like hello world from our exercise in the last lecture, but there are situations where we might want to have a function that's an argument to another function where we don't want to give a name. And so for that purpose, we'd use something called an anonymous function. Now we have an example here with a function called divide by 10. So we have the def keyword that says this is a function. The function name is divide by 10, and it takes a single argument x. The output is x divided by 10. So we're going to create a list of numbers and then use the map function to apply the divide by 10 function to each of the numbers in this list called numbers. So map will take each of the values in a list or an iterable and send them one by one as inputs to a function. And then we're just converting this to a list in the end because a map object is similar to a list, but it doesn't actually run the function on everything. So it's very fast to create a map object. Running a list will actually sort of concretize it. It will make it into a list in the end. And so we have our list of numbers that we have initially, and then we have a list of numbers divided by 10 because we've applied the divide by 10 function to each number in numbers. But this function is very simple. We don't necessarily want to have to define a function like this for everything we do in Python where we want to, say, reuse our code. So in this case, all we're really doing is dividing by 10, and this is really trivial. So instead, we can just not give it a name, and we can use what's called a lambda expression. And so here's another example where we create our list of numbers. We're doing something similar with list and map. The white space here is a little different than you may be used to seeing. All I'm doing is I'm splitting up this statement from the previous case into multiple lines. And so this open parenthesis here is closed by this parenthesis here. You can see there's sort of some highlighting going on in the Jupyter notebook here. So this green color matches the green color down here. And then the map function also has matching parentheses. And I've sort of used the indentation level to denote where this starts and ends. And so before, we had used the function divide by 10. Here, I'm using a lambda expression. Now, a lambda expression is like a function in that it takes an argument and returns a value, but it only works with one-liners, or really short pieces of code. You don't want to write a complex function as a lambda expression. So in this case, we're taking an input x, and we're returning x divided by 10. And then we're using numbers as the input to the map function. So we're mapping numbers to this function x divided by 10. And so if I go ahead and run this, you'll see it's exactly the same output. It's just a different way of expressing it. And we never had to define a function like this divide by 10. So it's just a different way of doing things. You don't have to use lambda expressions ever. You could always just use a function in place of a lambda expression, but they can simplify code, and if you're reading someone else's Python code, you might encounter them. So it's a good thing to know about. You can also assign a lambda expression to an identifier, which is very similar to giving a name to a function. So we can take our function with input x that returns x divided by 10, and then we can give it a name like divide by 10, and it works just the same way you'd expect with a named function. But unlike functions defined with def, Lambda can only create what's called one-liners, as I mentioned, which are really simple pieces of code. And if you're curious about Lambda expressions, more can be found in the Python tutorial on Lambda expressions here.